Alrighty, I thought I would solve this SAT practice problem in 3 different ways. And I will do it in increasing speed. I'll explain the ideas that if you are able to catch, then you can solve this super quickly. Okay, so this guy says if negative 2x squared plus 5x plus 10 all over negative x plus 4 is equal to 2x plus 3 minus a over negative x plus 4. What is the value of a? So we have a division of two polynomials over here, and then this is our quotient over here. That's my interpretation right away. So here's method one, the slowest way that I thought of, okay? We could, of course, just do synthetic division or long division. If we remember how to do long division, here's the divisor, goes outside. The dividend, that's the right terminology, goes inside. Okay, so we want to get from, we look at the biggest degrees, basically. We want to get from negative x to negative 2x squared. So what do we multiply? We can multiply by 2x. So minus parentheses, we multiply this 2x with this minus x plus 4 over here. So we get minus 2x squared plus 8x. Okay, we want to subtract these two rows. So we get negative 2x squared plus 2x squared, that gives us 0. 5x minus 8x, that's minus 3x. And then we bring down the plus 10. All right, so now we look at the biggest degrees again. We want minus 3x. How do we get minus 3x from negative x? We just multiply by a positive 3. So minus, multiply 3 to negative x plus 4, so that's minus 3x plus 12. So then we get a minus 2 as a result, okay? So the remainder is negative 2, so the quotient, if we remember how to do long division, the quotient is 2x plus 3 plus the remainder, which is negative 2, over negative x plus 4, the divisor, okay? Which we can move this minus sign out in here to match the notation up here. And so the answer is 2. Okay, here's method one. Alrighty. Not bad. Synthetic division will make it even quicker. I'm not going to go over that. Here's method two if we don't want to do long division. Apologies for the erasing. Okay. Let's just write the algebraic expression on both, or the equation. And let's work with equations like we typically do. Okay, so what if I multiply both sides by minus x plus 4? So what happens? Well, on the left-hand side, these two cancel, so you're left with minus 2x squared plus 5x plus 10, okay? You got to distribute this minus 2x plus 4 to all the terms over here, so you just got to be careful. So 2x, I'll write it out, minus x plus 4 plus 3 minus x plus 4, and then we get a minus a over here, okay? So if we expand the right-hand side out, that's minus 2x squared plus 8x minus 3x plus 12. Do some of these terms sound familiar from the long division? Hopefully they do. Okay, let's combine these two like terms in the middle. That's a plus 5x. Okay, let me shift these things over. Now let's start matching terms. This term matches this term over here. This plus 5x match. Okay, so 10 must be 12 minus a, so our a equals 2, like we said earlier in method 1. Here we go. Here's method number 2. Now, here's the quickest way that I thought of. So method 3 now. Let me do this cutting. Oop, didn't get everything, but much quicker. Okay. Method 3. This is remainder theorem, if you heard of it before. Okay, you have to first and foremost recognize that this is just a long division, where this is the, once again, the quotient, and here is the remainder. And when we divide a quadratic, so a polynomial with degree 2, with a polynomial of degree 1, we know that we should get a polynomial of degree 1 as a quotient, which we do right over here. Okay, so the remainder must be a constant, a, which it is in this case, right? All right, so how do we get the remainder? So let's suppose f of x is the numerator of the left-hand side, a function, okay? Basically, when we do f of x divided by negative x plus 4, we should get a quotient and some remainder, okay? This remainder, again, is some, in this case, is negative a over negative x plus 4. Negative a because of the minus sign right over here, okay? So we can get that constant a by just f of 2. What is f of 2? Minus 2 times 2 squared plus, sorry, not f of 2, sorry, f of 4. Basically, where you have a divide by 0 problem, okay? So it would be -2, so I'm plugging into our f of x definition up here. So it'll be 5 times 4 plus 10, okay? So this is just -2 times 16, that's -32, plus 20, plus 10, this is -2. This gives us our minus a. So a is equal to 2, once again. So this is the quickest way, in my opinion, okay? That requires us to, first and foremost, recognize that, well, you kind of need to know this for method 1 as well. Not so much method 2, but for sure method 1, you need to know that this right-hand side is a quotient and a remainder. This is doing a long division. Okay, so you could either method 1 do the long division yourself, or method 3 over here, recognize that you just need the remainder. So you use that theorem where you plug in the point where that factor becomes a 0. So in this case, when x is equal to 4, because it'll be a 0 on the bottom right over there, okay? So you get that. -2 would be your remainder, and therefore, because the negative a over here, once again, a is equal to 2.